Hello everyone, my name is Ross McKitrick. I'm a senior fellow at the Fraser Institute and a professor of economics at the University of Guelph. I'm sorry I can't be with you in person, but I appreciate the chance to present some information from the report that I published earlier this month about Ontario's Green Energy Act. And in my presentation today I'm going to go over some of the environmental consequences and the economic consequences. I know that for a lot of communities around Ontario, the Green Energy Act has some very practical consequences as you're struggling with whether to proceed with installation of wind turbines, whether to look at getting solar panels installed on properties and so forth. I'm going to take more of a macro view, looking at it in terms of its effect on the overall economy, but I will make a few comments at the end that might have some bearing on decisions at the local level. The Green Energy Act was introduced in 2009. It has the stated goals of reducing conventional air pollution and greenhouse gases, and the mechanism is to replace the coal-fired power plants with renewable sources like wind, solar, biofuels, and small hydro operations. The other goal is to promote economic growth and job creation. And in my report, I'm looking at whether the Green Energy Act has succeeded in achieving these goals. So the three questions that I ask are: will the Green Energy Act materially improve environmental quality in Ontario? Is it a cost-effective plan for accomplishing its goals? And are the economic effects on households and leading economic sectors likely to be positive? My findings, to summarize, are as follows. First of all, it is unlikely the Green Energy Act will yield any environmental improvements beyond those that would have happened anyway. The Green Energy Act in fact might actually result in increased air emissions, and I'll explain how that can happen. The most important finding here, though, is that we could have achieved equivalent air quality improvements at a fraction of the cost through another plan that was considered at the same time, or a few years previous to the Green Energy Act, that would have involved a simple retrofit of the existing power plants. The second part of my findings, the approach that was taken under the Green Energy Act is already 10 times costlier than that retrofit option I mentioned, and yet it's only yielded a fraction of the power needed to replace the energy we get from the coal-fired power plants. Wind energy has a particular problem in Ontario because it tends to peak when the system demand is at a minimum, and vice versa. 80% of the power we're getting from wind energy in Ontario comes at a time when we have surplus baseload power already, and so that power needs to be dumped on the export market, and we do that at a significant financial loss. Wind turbines also operate at less than a fifth of their rated capacity about 50% of the time, and as a result it takes 7 megawatts of new installed wind energy to replace 1 megawatt of coal-fired generating capacity. Finally, the Green Energy Act, in terms of its economic effect, it's already moved Ontario to having some of the highest electricity prices in North America, and experts both within and outside the government are forecasting a further 50% increase in the power rates that people pay. This is not entirely due to things like wind and solar energy. There are also costs associated with maintaining and refurbishing the nuclear plants, but the Green Energy Act is a major driver of those cost increases. The provinces claim that the Green Energy Act will create 50,000 jobs was simply a fabrication. They never had any economic analysis behind it. They've since admitted in their response to the Auditor General's report that they had no factual basis for this claim, and in fact, when they came up with the number, they didn't take into account the job losses in other sectors that will arise due to rising electricity prices. Also, most of those jobs that they refer to would at best be 2 or 3 year construction jobs associated with erecting the turbines, but there are no long-term jobs associated with that. So first of all, moving to the air quality issue. As many of you probably know, air quality has been improving in Ontario for a long time. We have air quality records in Ontario for most of the province that go back to the early 1970s. In a few locations they go back into the 1960s. This is a graph showing a couple of the longest records for sulfur dioxide levels in the province. One of them is from Sudbury, a record that goes back to the 1950s, and another one for downtown Toronto. And the horizontal line in the graph here represents the most stringent clean air standard for Ontario. You can see that there's an interval in the 1960s and up to the late 1970s where both Toronto and Sudbury had sulfur dioxide levels that were high compared to the clean air standard. but because of the air quality measures that were put in place in the 70s and the 80s, those emission levels and the air contaminant levels have dropped until now at the point we're at here in 2013. Sulfur dioxide levels across the province are basically zero. They're only monitored in 5 locations now, and the typical readings, including in downtown Toronto and up in Sudbury, would be somewhere between 0 and 4 parts per billion most times of the year. So sulfur dioxide has not been an issue now for about 20 years in the province of Ontario. This is a graph showing total suspended particulates. Unfortunately, our air quality monitoring record in Ontario stopped measuring TSP in the late 1990s, except for a few locations where some readings were taken in the early part of the 2000s. But you can see again there's a downward trend there. The worst levels were in the 1960s and 70s. They've since dropped to below the clean air standard, which again is this horizontal line that you can see. We don't measure total suspended particulates. We do measure related quantity called particulate matter smaller than 10 micrograms. Particulate matter smaller than 10 microns in a few locations, and then most locations it's ultrafine particulates, or PM2.5, that gets measured. And so those records aren't directly comparable to the total suspended particulates, but they too show the general pattern of declining particulate levels in Ontario air. Even in some of the places like Hamilton, where there's still a concentration of heavy industry, the air quality is almost always within the limits of our air quality standards. Carbon monoxide, this graph here shows that the readings, even back to the 1970s, tended to be low compared to the clean air standard, and have generally gone down. Most sources of carbon monoxide are from trucks and cars, and they've been getting cleaner, so even though there are a lot more cars and trucks on the road now than there were back in the 1960s and 70s, the carbon monoxide levels are well below the 6 part per million standard, and carbon monoxide is really not an air quality issue anymore in Ontario. Ozone is a persistent challenge for Ontario. It's not directly emitted by any source. It's instead formed within the air through chemical reactions with the precursor compounds that come from cars and trucks and power plants and other stationary sources. This graph shows the ozone levels, again in Toronto and Sudbury. I just picked those 2 locations for comparison. The gray dots here are Sudbury, the little black crosses are Toronto, and these show the 99th percentile readings each month, so the monthly maximum readings, because most of the month, even in Toronto, the ozone levels aren't typically an issue. It's just there'll be occasionally in the summer, there'll be a few hot days, hot sunny days. Those are the kinds of days that ozone forms, and then the levels spike for a couple of days and then come back down. So for ozone, we tend to look at the monthly maximums rather than the averages. In Sudbury and a lot of outlying areas, the levels will go up to between 20 and 40 parts per billion. It's below the 65 part per billion standard. That's where we get air quality concerns. In Toronto, you can see back in the 80s and the 90s, we were getting exceedances on a fairly regular basis, but now, as of the last 5 or 10 years, those exceedances have pretty much ended. So all year round in Ontario now, we have air quality that's typically good or very good, and you can look up air quality readings all over the province on an hourly basis online, and you'll see that we don't really have a problem in Ontario of bad air or worsening air quality. And in fact, by the time the Green Energy Act was introduced, it was already the case that we had brought most types of air pollution under control, and the other issues like ozone and ultrafine particulates were trending in the right direction. So every year, when the Ontario Ministry of the Environment publishes its annual survey of air quality in Ontario, the report always begins with pretty much the same wording. It always begins now with the statement that air quality has improved significantly over the years, which is true. It lists the main air contaminants that we're interested in and shows you the graphs of how they've improved over time. The levels have gone down, and the emissions have decreased from both vehicles and industry. And starting in 2010, the air quality criteria were not exceeded for nitrogen dioxide and for carbon monoxide at any of the 40 locations around the province where it's monitored, nor were the standards for sulfur dioxide or ultrafine particulates exceeded. And so typically in Ontario, all year round, we have good air quality. Now, you may be surprised to hear some of that because you've heard a very different story from the province. You've heard that we have air quality problems that are getting worse and worse, and they're killing thousands of people, sending tens of thousands of people to the hospital. And in particular, they pointed to the use of coal-fired power as the source of this problem. And so in the Ontario Ministry of Energy Long-Term Energy Plan, there's a paragraph here that talks about our use of coal-fired power in the following terms. Worst of all, Ontario relied heavily on 5 air-polluting coal plants. This wasn't just polluting our air, it was polluting our lungs. Doctors, nurses, and researchers stated categorically that coal generation was having an impact on health, increasing the incidence of various respiratory illnesses. And now they refer to a 2005 study that found that coal was causing $3 billion worth of damages to health and well-being and threatening the lives of children. I'm going to refer back to this 2005 study quite a few times because the province really leans on it whenever they want to defend the Green Energy Act, as they do in this case, as they did in their response to the Auditor General's report. This 2005 study, which I imagine most of you have never seen, it was kept confidential for quite a while after it was released, but it does have some very important information in it for understanding why the Green Energy Act was a misguided effort. Now, looking at the power generation facilities in Ontario and in the U.S. Northeast, this is a diagram from the Ontario Ministry of Energy website which shows the locations of all the power plants in our neighborhood, and they are scaled by the size of their sulfur emissions. So that gives you an idea roughly of the size of the power plants and the volume of smoke coming out of the smokestacks. These include coal as well as natural gas-fired power plants. Now let me show you the effect of removing Lambton and Nanticoke, our 2 major coal-fired power plants in southern Ontario. So this is what the diagram would look like if we take Lambton and Nanticoke out. And we are supposed to believe that that change will have a dramatic effect on air quality in southern Ontario. Now, just looking at it in those terms, it doesn't seem all that plausible. And in fact, when we look in the details of this 2005 study, we find that closing the Lambton and Nanticoke power plants won't have much of an effect on air quality in southern Ontario. This study was prepared by an independent consulting company and an engineering company in Ontario that specializes in air quality and meteorological modeling. And they looked at 4 scenarios for electricity generation in Ontario. A business as usual case where we just spend the money we need to maintain our existing power plants and generating facilities and power lines. And then 3 changes. 2 of them would involve expanding nuclear and gas enough to replace the coal-fired power plants, and another one would involve taking the coal-fired power plants, bringing them up to date, retrofitting them with state-of-the-art and very stringent pollution control systems. And none of the scenarios, though, looked at or recommended wind, solar, renewables, or any such strategy. If the coal-fired power plants were closed, ozone would be reduced by about 0.08% in Toronto. PM10 would be reduced by about 2% in Toronto. And in 57 locations around the province that the analysis looked at, the numbers would be about the same. The only 2 locations where there'd be slightly larger reductions would be in the vicinity of the power plants themselves. Now, if that's closing the power plants, if instead we went with the retrofit option, which is maintain them, keep them running, just put some stack gas controls in place at a much lower cost than what we're talking about with replacing them, then we get identical reductions in ozone, reductions again very small, about 0.08%, and a slightly smaller reduction in PM10. 0.8 micrograms per cubic meter as opposed to 1.1 micrograms per cubic meter. Really a difference that would be unmeasurable and unnoticeable. Now these are the only two air contaminants that were looked at, and that's again because all the other air contaminants, sulfur, carbon monoxide and so forth, just aren't issues in Ontario. So ozone and PM10 are the only ones that were looked at because they really are the only ones that at this point figure into our air quality index. So the upshot of that analysis is that this report that the province likes to refer to, when we look into the numbers, what it actually said was that yes, you would get a slight improvement in air quality from closing the coal-fired power plants, but it would really be about the same as you would get simply by completing the retrofit that was actually underway at the time the report was published. The retrofit was suspended at that point because the province announced they were going to close the plants. But had they simply completed it, they would have already achieved air quality improvements identical to closing the power plants altogether. And in that scenario, we would get to keep those power plants and continue to make use of them for at least another 20 or 25 years. And that would have quite a few benefits for our power cost situation, as I'll explain. First of all, if we think about the grid that we have a power distribution grid which is geared towards our existing power plants. If we shut those down and replace them with wind facilities, well, the wind facilities are scattered all over the place, all over the province. And so we have to build a grid to accommodate those new wind facilities, and that's going to be very expensive. It also poses a lot of real engineering challenges. It isn't just a matter of running lines out to these wind facilities. It also involves trying to configure the grid to cope with the very different type of power that's generated from wind facilities, this constantly fluctuating up and down and distributed form of power, as opposed to two central locations that generate a very predictable, steady form of electricity. The Auditor General pegs this cost at about $1.5 billion in new transmission lines just to accommodate this change to the grid. Now, in Ontario, we have, as with most places, we have a couple of different types of power generation facilities. One type would go under the heading baseload, and another type would go under the heading of variable or scalable power source. The baseload power just provides a steady, even level of power all through the day, and that's the kind of electricity we get from nuclear plants and hydro generation facilities. And then we use the scalable facilities, like the natural gas and coal-fired power plants, to fill the gap going up and down during the day as system demand goes up and down during the daily cycle. So we have, at this point, a surplus of baseload power in Ontario. This graph that you see here is from the Auditor General's report. It shows the peak electricity demand in Ontario as the black line here. And that's the line showing the daily peak. That's what we need to be able to accommodate on a daily basis. And it amounts to about 25,000 megawatts in Ontario. And it's been declining the last few years. This is where we are now. And it's expected to be roughly constant out to 2025 or so. And so we don't face an immediate need for new generating facilities. The baseload power that we have, the installed capacity of our electricity supply, is given by these green bars here. And so you can see that we have more than enough power generating facilities. What it means is that when we continue to add wind generating facilities to the grid, we're adding to our baseload capacity, and we're adding power there that we don't need. The wind power is unpredictable. When a new wind installation is put in place, it has to be backed up by a natural gas facility that would be rated at about 50% of the power of the wind facility, because if you have the wind tied into the grid and you're relying on that power and then the wind direction changes or the wind disappears, you can't just do without the power if you were expecting it. So natural gas facilities need to be running in the background to take up the slack as the wind comes on board or disappears. And so we're adding a combination of wind and gas into a situation where we already have more than enough baseload and scalable power to meet our needs. Now, where this takes us in the future is if we continue to add this wind energy, and if we continue to add it under the current rule that says the grid operator has to buy any wind power that's available. So the Green Energy Act requires the grid operator, if those blades are turning at someone's wind turbine, they have to be able to sell the power. So the grid operator has to take that power. So it has to be considered a baseload source. So if we continue to add more wind power, we can't absorb it to an indefinite amount. You have to start to remove other sources of baseload power. So additional wind is going to displace either nuclear or hydropower. And so think of what we're doing here. We're replacing nuclear and hydro that don't have any air emissions associated with them, and we are replacing them with a combination of wind and natural gas. And we may get to the point where we have to start taking nuclear generating units offline fairly soon if we continue to have this surplus of baseload power. So wind is not displacing coal at this point. Wind is displacing nuclear and hydro, and it's replacing zero emission sources with the wind-gas combination that has air emissions attached to them. So in this sense, the Green Energy Act may very soon start to lead to increased air emissions. Not necessarily large increases, but just enough to completely defeat the purpose of the Green Energy Act in the first place. Now, looking at the cost efficiency question, that retrofit option that I referred to, we can add to that not only the cost of dealing with the NOx, the sulfur, the PM10, the main air contaminants, but also adding in the cost of purchasing greenhouse gas offset contracts that would zero out the CO2 emissions associated with these power plants. And here again, the numbers coming from that 2005 report show that the retrofit would pretty much eliminate the PM10 emissions from the power plants. It would nearly eliminate the sulfur and the NOx emissions, and that's why you would have air quality improvements almost equivalent to just shutting the plants down altogether. But under this scenario, we maintain the power plants. We continue to use them. We continue to get all the benefits of very high quality generating facilities that provide scalable power at a low cost for the province. Now, when the Auditor General began looking at the Green Energy Act, one of the first things that he discovered was that the province hadn't done any analysis of the costs of implementing this act. And the whole thing was rushed through. It was based on very little advanced thought, very little consideration of the effects on households and industry. At this point, the numbers in the Auditor General's report indicate that Ontario is facing increased electricity bills that are costing us about $2.2 billion per year. We also have the global adjustment to our power bills, and the portion, the increase rates that are due to the renewable energy contracts are pegged at $2.7 billion per year. The new transmission facilities will cost about $1.5 billion. So at this point we are looking at costs of about $5 billion per year. And bear in mind, that's not to replace the power from the coal-fired power plants. All we've got so far is a fraction of the power that would be needed to replace the coal-fired power plants. So that's $5 billion per year. What would the retrofit option have cost? That 2005 report pegs it at $817 million per year. So we are currently looking at $5 billion per year as opposed to $817 million per year to go the green energy path route. Now, when we look at the development of wind energy in the province, this graph shows the installation of wind generating facilities starting in 2006. The line here represents the maximum installed capacity, but as you can see, the actual output from the wind grid, that's these little dots here, they never actually achieve the stated output of the facilities. Typically, the output is somewhere down here, and it's only occasionally based on the season of the year and the time of the day when power output may ramp up from the wind grid. What we actually get is illustrated by this histogram here, and let me explain how this works. On the horizontal axis, it shows you the wind energy output as a fraction of the total capacity. and the vertical axis shows the percent of time that the system is receiving power from the wind facility. So this first bar here indicates the total percentage of the time that wind energy is running at about at below 10% of rated capacity, and that's 25% of the time. So these first two bars indicate 47% of the time the wind energy system is running at below 20% of its rated capacity. And it's only about 4% of the time, the 3% bar here and the 1% bar added together, that we get 80% of the rated capacity of the wind system coming through. So about half the time the wind energy grid is giving us only 20% or less of its rated wind energy capacity. The times when we get the most power from the grid are it's times in the late fall, and also during the day. It's in the very early morning before the main increase in power consumption as the province is waking up and people are turning on lights and appliances. So it's times of the day and times of the year when the system demand is actually at a minimum. This graph here shows the total power demand of the system graphed against the output of the wind energy grid on the vertical axis here. And you can see there's a slight downward sloping relationship here. Most of the time that we get power from the wind energy system, it coincides with times when the total system demand is relatively low. When we get into the high system demand periods, between 20 and 25,000 megawatts, that's when the wind energy grid drops off quickly in terms of its production capacity. So for that reason, with wind energy, we can't just install 1 megawatt of wind energy and replace 1 megawatt of coal-fired power plants. Now, Lambton and Nanticoke have 7,500 megawatts of capacity between them. Wind is supposed to replace 64% of that under the long-term energy plan. But wind only operates on average at 30% capacity. It's a high of 41% on average in November, when demand is very low in Ontario, or relatively low. We have our peak energy demand in July, when it's very hot, people have their air conditioning on, and that's when we get the minimum of wind energy. We get 14% of the rated capacity on average in the month of July. So in order to get 1 megawatt of year-round power from wind energy, you need to install 7 megawatts of new wind capacity. So if the province goes ahead and really achieves 4,800 megawatts of capacity, that doesn't mean they need to install 4,800 megawatts of wind energy. They need to install 7 times that in order to have year-round 4,800 megawatts. And so at this point, the costs of the wind-related programs in the Green Energy Act are about $4 billion, and that gives us, at present, only 10% of the planned wind capacity that the province says we eventually are going to hit. So, putting it all together, on a scaled comparison to the retrofit option, the Green Energy Act is currently costing us about 10 times as much as what we would have spent if we'd simply gone with the retrofit plus the greenhouse gas offset option. If we actually go to the level of green energy, and in particular of wind energy, that the province says they want to get to, in other words, replacing 4,800 megawatts of generating capacity on a year-round basis with wind energy, it will take us up to 73 times the cost of the retrofit option. And what do we get for that in terms of environmental benefit? We get no environmental benefit that we would not have had with the retrofit option. So I'm comparing apples and apples here. I'm comparing two plans that would yield the same environmental benefit, and one of them, if we actually pursue it as the province intends, will be 73 times the cost of the other. Now, things get even worse when we look at this timing mismatch. The Green Energy Act mandates that the grid operator has to buy all the available wind power at 13.5 cents per kilowatt hour from wind turbine operators. 80% of that power comes at times when we already have surplus baseload, and we dump it on the export market. The wholesale price on the export market is typically 4 cents per kilowatt hour or less. So we're buying power at 13.5 cents per kilowatt hour, selling it at 4 cents per kilowatt hour. We are losing $24,000 per hour that wind turbines operate in this province. So a lot of people listening to this presentation will have an annual income of about $48,000 or less. That means that all the work that you do for an entire year is just enough to pay for 2 hours of losses from our wind grid. We are losing about $200 million per year just on this aspect of the Green Energy Act. Now, scaling up to the macroeconomy and where this is all taking us. Ontario used to have some of the cheapest electricity rates in North America. That was one of the ways that we built a manufacturing sector in the province, by being able to offer to large-scale manufacturing operations very inexpensive electricity from our mix of hydro, nuclear, and some fossil energy. We've thrown that comparative advantage out the window. We're now among the most expensive sources, or we now have electricity prices that are near the top of the list. And we have not even finished with the electricity price increases. As I mentioned, the Auditor General and also private sector forecasters that have analyzed the provincial government's plans say we're in for another 40 to 50% increases across the board for all our power user groups. At the same time, in the United States, electricity prices are declining because of the shale gas revolution and a few other changes that are happening to their electricity grid. So their electricity prices are going down while we're on an upward trajectory. And the province, in recognizing this, they are trying to shield some of the large industrial users by promising a new subsidy program for them. There are lots of strings attached. The firms need to spend money on hiring that they wouldn't otherwise do, so it's not necessarily going to save them money. But the bigger problem here is all that does is it transfers the cost onto taxpayers. So taxpayers, or in other words households, that are already dealing with their own reduced budgets because their own household power costs have gone up, will also be footing the bill to pay for the subsidies for industrial groups, which the province is proposing as a way of trying to patch up a problem that they created with the Green Energy Act. So it's no solution, and it's not really plausible that a province that's running a deficit of the size that we're now facing can commit to these long-term subsidy programs. Certainly the green energy benefit for Ontario households that only partly covers the cost of the rising energy bills that we're facing, that's scheduled to be eliminated at the end of 2014. And so subsidy programs really are not a solution to the underlying problem that we're facing, this trajectory of rapidly increasing electricity prices in a context where North American electricity prices should be going down, and they are going down in a lot of jurisdictions that we compete with for manufacturing activity. So in the report, we do a detailed econometric analysis of unit cost elasticities for three major sectors: forestry, mining, and manufacturing. This is looking at what's the cost, the overall percentage cost increase for production, for unit production costs in Ontario as a result of the electricity prices going up. And I used StatsCan data going back to the early 1960s, as well as data from the National Productivity Accounts and also Ontario Ministry of Energy data to characterize how input cost changes in the past have affected overall manufacturing productivity and unit production costs in all these sectors. And using that model, we can then look at what would happen to unit costs in Ontario from a 50% increase in electricity prices, and how that would affect the rate of return to investment. So the results are that the manufacturing sector, not surprisingly, would be hit the hardest. The rate of return to capital in manufacturing, if these electricity cost increases go through, the rate of return will go down by 29%. The rate of return in mining will go down by 13%. The rate of return in forestry will only go down, our prediction is under 0.5%, and that's because the forestry sector it's energy intensive, but it's not electricity intensive. At least in recent years, much of the energy the forestry sector has gotten has been from sources other than electricity. So manufacturing, though, is the real concern here, because we've already lost 250,000 manufacturing jobs in the province of Ontario over the past decade. We are on a downward path in manufacturing. That wasn't necessarily due to rising electricity prices. That figured into it, but we also had an appreciating currency. We faced a number of challenges. There was a recession in 2008. So we have a number of factors that have dealt a real blow to manufacturing in Ontario. And the other factors are outside of our control, but one of the things that is under the control of policymakers is whether we're on a trajectory towards increasing electricity prices or a trajectory towards decreasing electricity prices. And if we stay on the path of increasing electricity prices, then we will face a competitiveness problem that the rate of return to investment in manufacturing in Ontario will take a further hit. And what that just means is that people will look elsewhere if they're going to invest in developing new manufacturing operations. And we'll also see a continued deterioration of manufacturing and employment in manufacturing in Ontario as a result. So that's bad news. And my conclusion from that is that we're not going to see this growth of 50,000 jobs or anything like it in Ontario as a result of the Green Energy Act. Quite the opposite. We're going to see an overall reduction in employment due to the continued losses in manufacturing and mining. Now, there's a related issue here which I don't touch on in the report, and that is the question of lost property values, the health effects of wind energy, the concerns at the local level that people have of what happens when the turbines appear. And this is something that it's difficult to quantify. We know from talking to people in real estate appraisal and who look at these kinds of issues that yes, property values are taking a hit in some areas due to the wind turbines. Where this is really going to play out, though, is in the courts. And here there are a lot of lawsuits that are pending because wind farms in the vicinity of a residential area may interfere with the customary rights for landowners to use and enjoy their property. And so wind farms may be deemed a form of nuisance. If they are seen to inflict damages in the form of reduced property values and negative health effects, then the courts may be called upon to assess liability. On April 22nd, there was an important decision from the Ontario Superior Court of Justice that although they didn't authorize proceeding with a lawsuit in one particular case, it was only because the project in question hasn't been approved yet. And the ruling, though, was they accepted the evidence that if the project goes ahead, there could be property value losses between 22 and 50% in the surrounding areas. The court also accepted evidence that if the project goes ahead, there will be negative health consequences for people living in the vicinity, and so they authorized the suit to go ahead if and when the project is actually approved. So the project doesn't even have to be built. It just has to be approved, and at that point the court recognizes that right away there's a loss of property values. So this is the news item. It was put over the Canada Newswire on April 23rd, and for anyone in a district that's looking at this issue, should we sign up with wind energy firms, and what happens if our neighbors sign up? Some of the important details of this are, as I say, the lawsuit would be approved to proceed even before the project is built. It's just the approval is the signal. The other important thing, though, is that the court recognizes that liability would be assessed not just against the wind energy firms, but also landowners who host the wind turbines. And so for landowners who are looking at the possibility of a revenue stream from hosting wind turbines on your property, what you also need to consider, and you'd need to take legal advice on this, is would I potentially be liable for damages if people in the district go to court and argue that their property lost value or that they are suffering from health damages as a result of the operation of the wind turbines in this district. This is a very important aspect of it. It's a very important aspect at the local level, and I think people need to study up on what's happening in the courts. There are, according to this news item, there are dozens of lawsuits that are waiting to proceed on this, and so I think landowners on both sides of this issue need to be getting some legal advice on where they would stand if these court cases proceed. So, to summarize, to finish up here, in addition to the issue of lost property values and the health costs of wind turbines, the Green Energy Act at the more macro level is going to drive down the rate of return to capital in mining and manufacturing, and that's going to lead to reduced investment and employment in the province. The province did not have an air pollution problem in 2009 that would have required intervention in the form of the Green Energy Act, and even if they had wanted to achieve some air quality improvements related to power plant operations, a relatively low-cost retrofit option was available that would have yielded pretty much the same benefits throughout the province at a fraction of the cost. We have a problem with wind energy in Ontario that because of the seasonal fluctuations, it takes 7 megawatts of wind to replace 1 megawatt of coal-fired power plants. As a result, if the province really does intend to hit that 4,800 megawatt capacity, it's going to make the Green Energy Act 73 times as costly as the retrofit option would have been. We are dumping most of our current wind energy on the export market because it comes into the grid at a time when it's not needed, and that's currently costing us about $200 million annually. You can think of that as the budget of either a small university or a relatively large hospital. Just think, we could build and operate a large hospital in the province for the amount that we are spending just to purchase wind energy that we don't need, that we turn around and dump on the export market. That is money that is just pure loss. There's absolutely no gain associated with it. And this has all put us on a trajectory towards the higher electricity prices that you are seeing each month on your energy bill. I conclude with a photo that someone sent me, a woman who describes the place where she lives. It used to be one of the most beautiful places in the province to live, and now this is what she sees outside of her window, and I would not want to look at that myself. So I know at the local level there are a lot of concerns about what happens when wind turbine farms appear. My concern in this report was primarily on the economic effects at the provincial level of the Green Energy Act. I have a lot of concerns with the negative economic effects, and so I hope that this presentation has been informative, and I hope that any community that's struggling with the street level and ground level impacts of some of these changes will take the time for thorough discussions and find out where you stand and understand why I think that the initiatives taken under the Green Energy Act are really not in the province's best interest, either at the local level or at the macro level. Thank you very much.